Hi roboticists, today we're diving into the exciting world of robotics software development. In particular in this video, I will guide you through a basics ROS2 application where we will create both a publisher and subscriber using Python, which is the essential way of communication in ROS2 and in ROS in general. So we will go through the ROS2 humble installation. We will set up our workspace and we will start to create 2 nodes in Python. So if you're starting out or dreaming of becoming a robotic software engineer, this tutorial is perfect for you. Why that? Because we are building a strong foundation starting from scratch, so you can use this in a sort of template for your future project. So without further talking, let's get started. So the first things that you need to do is to go to this website. I'm gonna put the link in the description down below, and we are going to follow the instruction of installing ROS2, in particular humble distribution, on your Ubuntu Linux 22.04 Jellyfish. Why that? Because you should already know that each ROS distro is built upon a certain distro of Ubuntu, and in particular Humble is built upon Ubuntu 22.04. So if you're starting with ROS2 or you are migrating from a ROS1 project, I would suggest you to start with the ROS2 Humble Oxpill. Why this distro? Because at the point of the recording of this video, which is January 2025, this distro is the most updated one and has LTS version. And if the latest distro is going to be Jalisco, but there are not so much project on that. So I would suggest you to start with ROS2 Humble Oxpill because the community, you are gonna find most likely a lot of project and repository built in Humble, and then switching and migrating from Humble to Jazzy is going to be very easy. The most difficult part, if you are migrating from a ROS project to another, is to switch from ROS1 to ROS2. But we will do a further video for the migration. So first, as I told you, make sure that if you install ROS2 Humble, you need to have a machine of where it's installed Ubuntu 22.04, and then here you will need to follow this procedure. So it's pretty much straightforward. So I'm not going to do that because I already have ROS2 installed, but basically what you will need to do is to copy and paste all these lines. So you need to check the local, make this sudo update, and so on and so forth. Check the local again in order to have the good language encryption. Then you need to set up the source. Just copy and paste, update the universe, because all the repository, you need to install the repository for the source of your ROS2 application. Then you need to install curl, and then download and clone this repository here, and then basically you will need to install the dependencies, run sudo apt update, then upgrades, and then the last things is to install this ROS Humble desktop, and then the final this one. So I will recommend to use this if you want to work with gazebo, RVs, and 3D tools, I would say. Okay, so then another important thing is this one, that you need once that let's say that you have created and installed your ROS2 handle. In order to check this, you can just type on the terminal ROS2. And then you will see that there's gonna be all the extension, the commands that you can run. So meaning that ROS2 is successfully installed in your system. Another important thing that you need to do is to source the setup bash file that is inside this folder. And an important thing that you will need to do is to source every time that you open a new terminal. So let's have a look inside the bash RC folder. So this is the bash RC folder. This is a hidden file. So if you scroll down, you will see this line. So your file will end up here if it's the first time that you use it. And then here you need to type this source apt ros humble setup bash and this source one. So this is gonna source all the humble environments, and this you are gonna source the colcon are complete. So if you don't know, colcon is gonna be our Catkin built tool that we had in ROS1. Okay, and this is the setup bash file of our ROS2 workspace. So here I have in my computer different workspace. For example, the basics ROS2. For some, I'm preparing a masterclass in ROS2, so I'm using different workspace. So if you want to create a new workspace, the first things that you need to do is to create a new folder. So let's do it right away. So open a new terminal. Then create a folder, and this folder will be the name of your ROS2 workspace, and we can call it, I'm gonna call it ROS2 YouTube, then workspace. Okay, and then navigate inside this. And create another folder src. Okay, then run colcon build. There we go. So since that we have created our workspace in order to work with, I will really recommend you to go inside your bash RC file and source the setup bash file of this workspace. In fact, if you go inside the install folder of this workspace, you will need to source this. Okay, and I will really recommend you to do every time that you open a new terminal. So let's do it. So just for example, copy and paste this. We're gonna comment this out. and here we're going to call it ROS2 YouTube workspace. This is for the purpose of this tutorial. Okay, so again, then if you open another terminal, the bashrc file is sourced automatically, and then now we are operating inside the this workspace that we have created. Okay, so as you might know, ROS2 works with packages, and inside the packages there's going to be our application. So the first thing that we need to do is to create a package where I would say we run a basic functionality. We will run a publisher and a subscriber. So migrate inside the source folder of your workspace. Okay, there's gonna be nothing here. So to create a package in ROS2, you will need to type ROS2, then package, then create the name of the package, and here we can call it let's say publisher subscriber tutorial in Python tutorial. Okay, it's quite long, but it represents exactly what we are about to do. So now we need to set up the build time, and this is because in ROS2 we need to define the build type if it's going to be in Python or in C++. So you should know that the package in ROS2 has to be written in Python or in C++. You are not going to have in the same package a file written in C++ and in Python. This is the main difference from ROS2 and ROS1. So here we need to cite the build type. There we go. And the build type is going to be element. So then if you type tap, you can see here the option. So if you type CMake, you're going to create a package in C++. And if you type Python, well, you know it. It's going to be a Python package. And then what you need to put here is the dependencies. Okay, and the dependencies, for example, here in Python, we need to type this one. So RCL, RCL Python, and standard messages. Okay, so here another difference between ROS2 and ROS1. So in ROS1 we had ROS.py and ROS.cpp, but then here in ROS2 we are going to have libraries that is going to be RCL, and then the client libraries that are built upon it and are written in C. And this allows you to facilitate the real-time communication between the hardware and the software, I would say. And I'm not going to the detail. You just need to know that from now on, from in ROS2, the client library is going to be RCL, I would say. And then since that this is going to be a very basic package, we are going to have only the standard messages. Okay, so type yes, and then you can start to build the package. So to do that, we will need to type colon build. Okay, there we go. So in ROS1, you had to go in your workspace and type catkin make. Now, since that the build tool is going to be colon, you need to type colon build. Okay, now we are ready to code inside this workspace. So let's run in the source folder of this package, and we are going to see that we have this package, but let's navigate inside it in Visual Studio Code. Okay, here we go. We are inside our ROS2 workspace, and this is our first package. So you can see here that the structure is going to be quite different related to a standard ROS1 package. So in particular, we are going to have this folder, which is named exactly the same here. We have this init file. You will not need to touch it. And then you're going to have this file here, some test, and the package. And here, if you want to install some dependencies, you will need to modify this, and then you're going to have this file. And here is where you are going to put and install your node that you are about to create. Okay, so where we will need to create the node in this package? Well, we will need to create here, okay? And so the application that we are going to do in Python is going to be a very easy one. So imagine that you're going to have a belt conveyor, and you're going to have a camera that streams live the position of the object. So what we wanted to do is to create a publisher in Python that publish the position of the object that is detected, and we are going to create a subscriber that gets this data and do some things. Okay, so let's create a new file, and let's call it publisher in python.py. So this should be a very easy one. Okay, there we go. Let's start to create our first node in Python, and in particular this is going to be a publisher. So we are going to import our client library, and then we need to import the node from the RCLPy node, because we're going to see that all the node will be inherited from this class, and then we need to import the string message type. So in ROS2 is a good practice to structure your node as a class. So all the classes are structured in the same manner. You're going to have the main section, you're going to define your class with a constructor and the method that you might have. So let's do it right away. So if, then this is a standard way to create and structure a class in Python. Then we're going to define our main. And then now we are going to initialize the ROS2 communication. And we can do it by typing rcl py dot init and then args. So here you're going to see a main difference between ROS2 and ROS1. In ROS1, when you initialized the ROS1 communication, you initialized also the node, you created the node, and here is going to be completely differentiated. So that's why that in one file you can have a different node. This is another improvement, but we will see in a later video. Then we are going to create an instance of the class that we are about to create, and we can call it object position publisher. There we go. Then we need to spin the node and then run rcl pi dot shutdown. Okay, so now what you will need to do is to create this class. So a class then is going to be object position publisher. And here we need to type node, and meaning that we are inherit from the class node, and this is really important. And then here we need to define our constructor. Okay, so in this constructor, we are going now to create the node. And to create the node, we are going to use a method from the upper class that is going to be node. And to do this in Python, you need to use the super function, and then init, and then the name of the node. You can see here that IntelliSense suggests you what we need to put as an input, and this is going to be a string, the node name, and we can call it object position publisher. There we go. Then here, what we will need to create is we need to create inside this constructor the publisher. So self.publisher, and then self and create publishers. So you can follow the suggestion, and then you need to type here the message type, and let's say that we want to publish a string, and then we need to define the name of the topic that we want to publish to, and we can set up as a string that is going to be object position. And here you need to type the queue. So now an important thing here is that we need to publish actual a position, okay? And to do that, we are going to use the function timer. So first of all, we are going to create a timer object, and we can call it a timer. We can define it timer, and then we need to create a timer. And this allows us to set up the frequency of publishing. Okay, let's set up for 1 second. Okay, and then we need to pass a function where actually the publisher publish a message of type string on the topic object position, and this function will be publish position. And so this function is going to be a method of this class, so we need to define it here, publish position. and this is going to be self because it's belonging to this class. So now we need to create a string object because the type of the message that we want to publish is going to be a string. So let's type message is equal to string. There we go. So then if you go on internet and you're looking for the message data type, you will see that the string type of message has a raw message that is called data. So that's why you need to type point and then data, and actually the string that you want to publish. And let's use the f functionality, and let's say that the object position Okay, so we are publishing this message of type string, and this is basically publishing a variable that is named count that simulates the position of the object. And since that the belt conveyor is moving, the count simulates the position of the object that is changing every second. Okay, and the frequency is set up here in the timer. And here we need to create as an attribute this count variable. Okay, but you will see later in the example how it's gonna work. And but basically for a hello world node, you can have just a string like a hello world. Okay, and here we are going to actually publish this message, and you need to type self dot publisher. There we go. Dot. We're gonna use the function publish. Publish what? Well, the message that we have created. Okay, and then if we want to print something on the terminal of the node that we are running, we need to use the getLogger function, and this is going to be self.getLogger, and then info There we go. And now we can count it up for the purpose of the simulation, I will say. Okay, there we go. This is the basic node written in Python in ROS2 environment. So again, here we have imported our library. We have created our main function where we have initialized the ROS2 communication. We have created a class of type object position publisher. So we have instantiated an object where we have used the constructor and the publisher. In the constructor of your node, you need to initialize the node, give it a name. Then you need to create a publisher, setting up the type of the message that you want to publish and the name of the topic. And then if you want want to publish at a certain frequency, you need to set up a timer. So you need to instantiate a object timer. Here we need to set up the frequency, and you need to create a sort of a callback function. We are gonna see later when we're about to create a subscriber. But basically, this publisher position is gonna be a method of this class that is always at a frequency that is set up to this timer. Okay, so then in this method that is our publisher activity, I will say, you need to instantiate a message of type string, because this is the type of the topic that you want to publish. And then basically you need to check the raw definition of your message that you want to publish, and in this case it's going to be data. And then since that is going to be a string, you need to publish a string. Okay, and then actually you publish by typing publish. Okay, and this node could stop here. But then if you want to print something on the terminal, you need to use the get logger function, and then this count is adding up in order to just for the purpose of this simulation and application. Okay, there should be it, but before to start, you need to install this node in your package. So you need to go in this setup.py, and here there's going to be some information about the maintainer, so on and so forth. But to install the node, you need to install it here. So in this entry point, here you need to type the name of the executable file that you wanted to create, and this is gonna be we'll call it in the same name of the file that we have created. So this is a pub underscore py, and this is equal to now you need to set up the name of this package, that is going to be pub sub this is going to be py tutorial. Okay, then the name of the file, that is going to be pub py without the extension py. So it's normal to set it here, but it will be normal to put it the extension py, but you will not do it. And then you need to type the function that you wanted to start it with, and this is going to be the main, this one. Okay, so there should be it. So before to compile, I want you that you download your extension, and basically if you go to extension, these are our extensions. So first of all, you will need to install this ROS extension from Microsoft, and you will see that all the Python script will be Python extension will be downloaded automatically. I will suggest you to download this extension 2, ROS snippet. Is a sort of IntelliSense for ROS, and then you need C++ and CMake. So these are the main extension that you want to have. Before to test it, you need to make this file an executable. So let's do it. Okay, let's test it now. So let's build the package. 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 Okay, we have a warning. Let's try to solve this. Let's go inside the setup and we could comment this out. Let's test it again. There we go. So the Qualcomm build successfully build our package without any warning. So this is deprecatable, so you can comment this out. Okay, so let's test it. In order to test, you can run this node, and in ROS2, what you're gonna need is to type ROS2, then run the name of the package that is gonna be pub sub Python tutorial, and then the name of the executable file that is going to be pub.py. Okay, there we go. So you can see here that this node is simulating the position of our object in a belt conveyor. So it's simply a way to publish a stream of data of type string. So again, this node is publishing a message of type string on the topic object position. So what we can do now is to create a subscriber that will subscribe to this topic, and it will do something. Okay, so let's do it. So now let's create another file, and let's call it subscriber python.py. There we go. So now let's import the same things here. So you can see that here you can use these structures as a sort of template. You will need to change the class's name. So since that this node is a subscriber node, and we want that this subscriber, I will say, get the information of the object where it is in the belt conveyor, and gives some instruction to a robot. So we can call it robot arm controller. So we are not going to do that, of course, because this is a simulation on how to handle topic message of type string. So if it's going to be a string, we don't do nothing. But this is a way to give you some kind of structure. So class. Then you need this class, and again here you need to inherit from the upper class node. Then you need to define the constructor of this class. And here, thanks to the ROS snippet, you can see that here you initialize the node, and we can call it robot arm controller. Now, what we need to do is to create a subscriber. To do that, we need to type self let's create a subscription object. And this is equal to self.create a subscription. And we need to pass it the type of the message, that is going to be string, and then the name of the topic that we wanted to subscribe to, object position. And I remember you that the name of the topic here has to be the same of this one. Okay. And then here we need to set up the callback function, self dot I will say listener callback, and then the buffer. So this callback function will be a method of the class robot control arm, and we need to create it here. And we need to pass here as an input a message of type string. Okay, so here in this manner we are going to create automatically a message of type string, because this callback function is getting automatically the message that is coming from the publisher. Okay, and if we are put this variable message here, is meaning that this variable inside this class is already of type string. So there we go. This is a simulation of, let's say, the movement of the movement of the robot arm based on the coordinates that we have received. So then we can let's say add here the logic of our robotic arm, but this is not the purpose of this basic tutorial. So basically that's it. So let's create an executable for this file, and let's add it here. So there we go. Again here the same logic. Okay, so we should have everything to start. Again, here I have put this, so none, so that should not working. Now everything should be good. Okay, let's build the package. There we go. So now let's run the publisher. So ros2 run, then the name of the package, that is gonna be pub/sub/py tutorial, and then the publisher node in Python. There we go. So this node, I remember you that is simulating a camera that is seeing the position of the object, and then this information will be useful to the subscriber, which is simulated to be a robotic arm that reads the information to make something, for example, to pick. Okay, of course we are not picking it, but it's just a way to get the ROS2 publisher subscriber architecture. So now again we have this node that is publishing a message of type string on the topic object position, and then we have the subscriber, which can run like this, pub, there we go, sub. So let's see what's happened, and you can see here that synchronously the subscriber is subscriber to the topic object position. So while there are these two nodes that are running up, we can check some useful tool in ROS2. So ROS2 topic list. There we go. We have the object position topic that we have. Then we have ROS2 node list. So we have this node that are up and running. And then another important thing is to see graphically the publisher subscriber architecture, and you can do it by RQT graph. There we go. So we have here the basic structure of a publisher and a subscriber, where we're going to have this node, object position publisher, that is publishing a message of type string on the topic object position, and then we have the node robot arm controller that is a subscriber to the topic and will make something. For something here it's very easy, we just print on the terminal the position that we have received. But in a real industrial application, you're going to have this node that, for example, will pick the object from the position that another publisher or a service will give to him. Okay, that's all for today. I hope that you enjoyed this video. If you like this video, don't forget to subscribe to the channel in order to do not miss any interesting topic. And the purpose of this channel, as you should already know, is to bring you to be a robotics software engineer. And if you want to deep dive in a more interesting topic, you can check out this course, this masterclass, and the purpose is to make you a robotic software engineer in 90 days. We are gonna deal with ROS1, ROS2, we're gonna run simulation and computer vision tool like OpenCV for 2D and Point Cloud library. You can check here the module here. The course is under construction, so it's gonna really complete. Since that the course is under construction, you can benefit a discount of 75%. I'm gonna put the code in the description down below. Okay, I hope that you enjoyed this video. This is a very basic one, and I hope to see you in the next video. And as always, keep learning robotics with ROS.